Welcome back, folks. In this video lecture, I'll be talking about the last topic of the chapter number 3. And in this one, we will talk about, first of all, what is percentile. And then also we will talk about what are quartiles. And then we'll try to simplify this question down here, which is given in front of us. So what is percentile? Percentile. So there is, first of all, by now we were talking about a one word, that is percentage. And if I take an example here, if you score, let's say, 90 marks out of 100, so what is your percentage? Percentage. Your percentage will be 90%. Now, the question arises, what is your percentile? So percentile basically means the rank in a given system. So let's say if there are 100 students, what's your rank in 100 student is. That's what percentile is. You scored 90% marks, but you are at the bottom, so means you are the last ranker. So your percentile is 1 percentile, because you are the last one among the 100 students. And compared to that, if you scored 90 and you are the topmost student, your rank is the topmost, so you are at 100 percentile. So percentile tells us about the rank of that particular number, where that particular number lies in a group. So hopefully you were able to understand the difference between the percentage and the percentile. Now, the next thing comes in our mind, what is quartile? So quartile is specific name given to the 25 percentile and percentile, not percentage. So 25 percentile is called as quartile 1, and then Q2 is 50 percentile, which is same as median also, and then Q3, which is 75 percentile. So that's what quartile is, specific name for the specific percentiles. Now, to find the percentile, we can use this particular formula, and then to find the quartiles, we can use this particular formula, this one. Now, rather than using these formulas, we're going to try and simplify this question by using the box and whisker plot, because by doing the box and whisker plot, it becomes super easy for us to find out the percentile. All right, so here, let me just erase this one, if I can quickly erase and make some space here. Now, first of all, if you are given some sort of a data, you must make sure you put the data in the ascending order. Whenever we are working with the percentile, this is where a lot of students make mistakes, so please make a note of this. I've seen a lot of students couldn't solve this a simple question, because what they do is they note down all these numbers, and they note down the number and start finding the percentiles and start finding the quartiles. But the biggest mistake they make is they don't put it in the serial order. I already put it in the serial order, but if you are noting down all these numbers are not sorted out if you're going to start writing these numbers. So you must make sure you sort out this data first of all, then start solving the question. All right, so this is the data given to me. So as I said, we're going to try and solve this question by using box and whisker plot. So I will select this data, and then let me just change the computer setting, because you may not be able to see it as the way the settings are. So let me share the complete screen, entire screen. Yes, share. And whoops. Now let me switch on this one. I'm going to quickly verify. Yeah, is it there? Yes, it is there. Now I wanted to find out first of all, determine the first and the third quartile, Q1 and Q3. You can use this formula. I'll encourage you to use this formula. Go ahead and use it, and you will get the answer also. So basic formula is equal to Q quartile exe, and then you select the whole data, and comma, you are finding the first quartile, so you're going to put this number, enter. Negative 6.5 is the quartile 1. All right, now I'm going to rather do it with the box and whisker plot, as I told you. So I'm going to click on the insert and then click on the charts. I'm going to draw a box and whisker plot. So here, let me find out the box and whisker plot. This is the chart we're going to draw. So before I start drawing the chart, I must select the data from which I wanted to draw the chart, select the data, and then click insert the chart and all charts. I'm gonna draw what kind of a chart? Box and whisker plot. This is what I'm gonna draw. Press OK. So we got the box and whisker plot. Yes, it is being shown on the camera screen. That's great. Now I'm gonna just put in the values. So data labels, data labels. So did you see that quartile 1 is down here, negative 6.5, which was here, which we figured out as quartile 1, Q1. And this down here is quartile 2, 4 is the quartile 2, and 9.5 is the quartile 3. And these are the boundary conditions. So lowest value is the lowest value of the data is 14 and the highest is 19, but then there is 37, which is an outlier for the data, and that's what we're gonna talk about now. So before I jump into solving all the rest of the questions, hopefully you were able to understand what is Q1, Q2, Q3, and this these values we can answer the questions by using these values. Quartile 1 is negative 6.5, quartile 3 is 9.5, and interpret the quartile 1. So 25% of the values are below negative 6.5, and then calculate the interquartile range. Interquartile range means Q3 minus Q1, that is the interquartile range, that is 9.5 minus negative 6.5. Remember, they will add up in this case because you are subtracting here. Down here, the formula is given to you. Q3 minus Q1. Q1 is a negative number. So IQR will be equal to 9.5 minus of 6.5. 6.5. Oops. So that is 16. IQR value is 16. So please make sure you don't make a mistake here. And then the next one is determine the lower and the upper limit of for the outliers. So this lower limit for the outlier is negative 14. Upper limit for the outlier is 19. So what is the meaning of finding the lower limit and upper limit? It's if you are taking the data, for example, you are doing some sort of a science project, or maybe I'll take a simple example here. You are trying to find the height of the average height of a Canadian man. So you're gonna start finding the heights and blah blah different things. So all of a sudden you see 300 centimeter height. Can anyone be 300 centimeter long? No. So you know that you collected 1,000 data points and one data point was 300. So this is more of an outlier. You know, maybe this reading was wrong, and how you got this reading, somehow this reading doesn't fit into your data. That's what it is. So that's what outlier is. Or another example can be if everyone in a classroom, they scored pretty much 50%, everyone, but one student has scored 99.99%, so he becomes an outlier. So that's what outlier means. So then the value which you need to restudy, that why that value is a little different, that's what outlier is. So outlier in this case, in this data, is 37. So you can clearly see this 37 is the number which is an outlier. And how you can find the outlier? Any value which is outside this limit. Lower limit, you can always find out of a data by using Q1 minus 1.5 times of IQR. So IQR in this case is 16. Q1 value was minus 6.5. So you can do the math and then you can find the lower limit, and same way Q3 plus 1.5 times IQR, you can find the value of upper limit and lower limit. Lower limit will come out to be negative 14, upper limit will come out to be 19. Any value beyond this, any value lower than minus 14 or any value above 19 will be considered as an outlier. And we've already constructed the box plot for this one, and we've answered all the question using box plot. So hopefully you were able to understand how to solve some of these questions. So that's it from my side for chapter number 3. I'll see you with another video. Till then,